Okay, so right now we're studying the topic of quadratic functions. And again, a quadratic function is something of degree 2. That's what makes it quadratic. And it's a function of x. In other words, we can plug in values of x, get out some values of y. And for every x value that we plug in, we're going to get out exactly one y value. So we pass a vertical line test. So a quadratic function is of the form y equals, and then we'll say ax squared plus bx plus c. Don't let the a, b, and c fool you. They're just in alphabetical order. And it means that a, b, and c stand for different numbers. We just don't know what they are now. But anything of this form is going to be called a quadratic function. And right now what we're learning how to do is graph it, talk about the axis of symmetry, and then also talk about the vertex. Okay? So what we're doing in this class that is different from what the textbook is showing you is I'm taking it a little bit out of memorizing formulas to get out some values, and I'm talking about more of a concept of taking something that's in a rectangular arrangement, trying to manipulate it into as close of a square as we can, adding the little bit that we have to do to make it a square, and then we're going to arrive in what's called vertex form. Okay? So here we're starting with y equals ax squared plus bx plus c. When all is said and done with our manipulation, we'll be at y equals a times x minus h quantity squared plus k. And again, I'm going to get some information out of this, just like when we talked about linear equations, and we had y equals mx plus b, where by inspection we could pull out the m and say that's our slope, and also the b gave us our y-intercept. Well, if we fall down into this vertex form, what we're going to see is that h and k are going to become h is the x value, k is the y value of my vertex. K is also going to be the maximum or the minimum of the function. Okay? And the a out front is going to tell us our amplitude, basically how we behave, whether we're right side up, upside down, and if we're growing fast or we're growing slow. Okay? So let's go through an example with this. Let's say we have something like y equals 2x squared minus 6x plus 7. Okay? And again, our goal is to manipulate this into something that looks like this. All right? So what we'd like to do is have some sort of perfect square quadratic that shows up in the middle of this function. So what we're going to do is we're going to try and force one perfect square. And I say one, meaning that we don't want to have 2x squared. We want 1x squared. And just like we see up here in our general form, we have a on the outside, and then inside is just 1x minus the h squared. So just like I went from a here to a there by factoring out, I'm going to factor out my a value here. So I'm going to get y equals, and now only factoring out of the two terms that involve x, I'm going to pull out that 2, and I'll get left with x squared minus 3x, and then plus 7. You can see that if I distributed this 2 back into this quantity here, I'd be right back to the step before me. So now what I've done is I've made it so that I'm trying to manipulate just one rectangular arrangement. So a visual here, when I see x squared minus 3x, just a reminder of what that is basically I have a rectangle that is going to be x by x, and then I'm also going to have this minus 3 concept. So if you're looking and thinking with algebra tiles, this is where we had 3 red rectangles and then 1 blue square to represent x squared minus 3x. Okay? So what we want to do here is we want to try and rearrange these 3 to be as close to a square as possible. In other words, we took x squared, we left one of the rectangulars x's there, and then we're going to take this other one and we're going to split it in half, so that we have half of it here and half of it here. So that if I thought about the sides of this, this is x, and then instead of plus 3, I have 1 1/2, or 3 halves, and this is also x by 3 halves, and the only thing I'm missing down here in this corner is the area that would be 3 halves by 3 halves. In other words, I'm missing an area of 9/4. So what I'm going to do here is I'm literally going to add in an area of 9/4 so that I can make a perfect square out of this shape that's x plus 3 halves by x plus 3 halves. And now when I add that 9/4 in, I'm also going to take 9/4 out. So if I add 9/4 and I take away 9/4, I added 0. I have a net change of 0. In other words, I haven't done anything to change the value of my output. I've just changed the way the machine works to get to that output. Okay? So, again, visual representation. I took b whatever my value in front of x was here, which is now -3, I divided it in 2. That's what this 3 over 2 is. Okay, and then I squared it, so that when I was all said and done, I have an x minus 3/2 squared, and I've added that 9/4. Algebraically, all I have to do is say, what's b over 2 squared? I don't like just memorizing formulas. I'd like you to see where it's coming from. But we take whatever this b value is, over 2, and we square it. So I'm going to get y equals 2 times x squared minus 3x. b over 2 is 3/2, squared is 9/4. So I add 9/4 inside. But notice I've added 2 copies of 9/4 on the inside. So if I added 2 copies of 9/4, I've really added 9/2. So if I add 9/2 on the inside, I've got to take 9/2 away on the outside. So I'm going to subtract 9/2. And then I still have this plus 7 that was up there to begin with. Okay? So again, what I've done here now is I've created this perfect square that I can now factor into a perfect square. In other words, it'll look like an x minus h squared. We're on our way to being done. So this becomes y equals 2 times x minus 3/2 squared. And then minus 9/2 plus 7. Well, I know 7 is 14/2. So negative 9/2 and 14/2 are going to combine to make 5/2. So this is plus 5/2. And now I've got to the form I want. Y equals an a times x minus h, quantity squared, plus a k. Now that I'm in this form, it's called vertex form, and it's aptly named again because the h and the k are going to be my vertex. Note the negative sign in front of h is what we need for our form. So down here, if I have a negative sign in front of my 3/2, my x value is just 3/2. Okay? And then my y value in our form has a plus in front of it. Down here, I've got my plus in front of it. So the y value is 5/2. That's going to give you your vertex. Now I know my vertex occurs on the axis of symmetry, so the equation for my axis of symmetry is going to be x equals whatever this number is. So the x value of the vertex is also the symmetry or the vertical line of the x line that is going to be my axis of symmetry. So my axis of symmetry in this case, AOS, axis of symmetry, is equal to x equals 3/2. Okay? Axis of symmetry is